Okay, so here is part two of lesson 6.4. Yes, we're on lesson 6.4. And we're on to the bisector theorem. And the bisector theorem states that an angle bisector in a triangle divides the opposite side of a triangle, and this is the bisector, and this is what they mean by the opposite side, because the angle is being bisected here. The divides the opposite side of a triangle into two segments whose lengths create a ratio equal to the ratio of the lengths of their adjacent sides of the triangle. To keep a long story short, this is our bisector because it's splitting angle A into two congruent parts. And it creates a situation where you have two similar triangles, okay? So what happens is CD is proportional to DB, and those two are proportional to their adjacent sides. So the side that is adjacent to CD is CA, and the side that is adjacent to DB is AB, okay? So we would set up our proportion CD over CA, or CD. Okay, so let me tell you the two ways that this could be done. You can do CD, and let's do some color coding here. So CD over CA, you could do that, is equal to DB over AB, okay? Even though that's not what I have written here, I'm going to write it. So you could do CD over AB is equal to DB over, oh, I'm sorry. So my error. CD over CA. So you could do CD over CA. That's why I put them in the same color. There's a reason for that. So you could do CD over CA is equal to DB over BA. That's one way to write your proportion. And I'm going to show you why it can be done. All right? Or you could write it as CD over DB is equal to CA over AB. Now, would there be a big difference here? Let's, for the sake of argument, start giving them some values, okay? So, for example, CA is, let's say, I'm going to say that that's 6 units in length. I'm going to say that this is 3, okay? I'm going to say that, that's, let's see, this is our unknown here. So let's say that that's unknown, okay? And I'm going to say that this is 4. All right, so as a matter of fact, no, let's say that this is 2. Let's make this a known value. So if we were to set up a proportion here, so CD, setting up that proportion, we would end up with 3 over CA, which is 6, is equal to DB, which is 2, and then AB or BA over 4. And if we were to multiply those using cross multiplication, we would get 12 on both sides, right? 12 is equal to 12, and that checks out. Now let's try it the other way. So that's this way here, okay? Where we have CD over DB, CA over AB. So the difference that we're seeing here is that we're putting in this first example, I'm using the one side in the first triangle over the other side in the first triangle. The corresponding side in the second triangle over the corresponding side in the second triangle. Okay, so here we're just creating a fraction with the lengths in the first triangle, and then in the second fraction creating a fraction, or of our proportion with the lengths of the triangles in the second, with the lengths of the sides in the second triangle. Okay, I'm feeling rushed here, so stay with me. Okay, so in this case, the reason why we can do the same thing is we're going to get the same exact numbers. Okay, so CD is 3 over DB, which is 2, right? So CD over DB is equal to CA, which is 6, over AB, which is 4. Okay, and again, if I multiply these up, cross multiplication, I get the same thing. But the gist of that, and I say all of this to say that in order to figure out angle bisector problems where you have missing sides and you have to solve for the missing side, what you have to remember is in an angle bisector, or using the angle bisector theorem of similarity, once you have the bisector, and in this case, this is the bisector, it splits these two triangles into proportional sides, and those sides are proportional to the adjacent sides. Okay, so two proportional segments, and so these, right, we could set these up in the first fraction of the proportion. These would be in the second fraction of the proportion. Okay, so here we go. So we took x over 30 minus x, and remember we said we could do that just like we did here, 3 over 2, x over 30 minus x, but if we go from first triangle to second, we have to keep the same order when we go, when we set up the second part of the proportion. So x over 30, x divided by 30 minus x is equal to 21 divided by 24. And then you just solve for x from there, okay, to figure out what x is, and in which case it is 14. Okay, so we're going to apply that to this last try it out. And it says to find the value of x. So the first thing that I see is that I have an x here, but then they tell me that the whole thing here is 15. So then this is going to be x minus 15, or rather 15 minus x. That's going to be the length of QRs, 15 minus x. That's x, and this value is 15 minus x. Okay, so it's basically saying the whole thing is 15, subtract this piece here, and then you'll get whatever is left over, and that would be 15 minus x. Okay, sorry if you can't really see, I wrote a little bit small, but that's what I wrote here, 15 minus x. So QR is 15 minus x over x is equal to 7 over 13. Okay, so it's 15 minus x over x is equal to 7 over 13. And then you do x, or you multiply x times 7, you get 7x, and then 13 times 15 minus x, and you get 7x is equal to 195 minus 13x, and then you add 13x to both sides, and you end up with 20x is equal to 195, and when you divide, you get x is equal to 9.75. Excuse me, I'm not showing you all the work. Okay, so we cross multiplied, set up the proportion, cross multiplied, solved for x. We got x is equal to 9.75.